Okay, welcome back. We're going to do some problem solving. It's section 22.1 for you. Just to look at here again, we have our Pythagoras and our right angle triangle, and then later on we'll do sine, cos and tan. So here we are here on page 16, and here's the theorem. If you have a right angle triangle, let's just name it up like this, then you have that the hypotenuse squared is equal to the sum plus of the squares on the other two sides. And that's Pythagoras' theorem, and we're going to jump straight into the exercises now, which start here. So let's get started. Actually, real quickly, let's do this example. So x will be equal to the square, because we're getting length, we'll go for length directly. It won't cost us anything in the marking scheme. It's a direct, straightforward application. Okay, that comes out to be the square root of 100, which is equal to 10. Then we're on to question 1. Find the missing areas. So in this case, it's addition. So it will be 12 centimeters squared, and I'll generally put square brackets around that. In this case, it'll be subtraction because it's a leg. So 28 take away 16. I can show my work. Okay, is 12. And gotta keep going. Is 12, and here we have subtraction again. It'll be 14 take away 6 is 8. Just to write down my work there. Now you don't have to write it down, or notice though it was addition when we're getting a hypotenuse, and it was subtraction when you were getting either of the two legs. Okay, on to question 2. Now we need to analyze this. We need to read the question for understanding. What is the area of the square drawn? So we're kind of applying the a squared plus b squared equals c squared formula here, but we do need to realize that it'll be subtraction when we've got a hypotenuse given. So that is 9 squared minus 7 squared. We could do that in the calculator, but we could apply the difference of two squares. A good chance to throw in an extra bit of maths, and it does make the mental maths easier. 2 times 16 equals 32. Units, because we want 10 marks out of 10, not 9, so we want our units. Okay, and that's that done. Use Pythagoras' theorem to, notice that the way, because it ends in an S, the plural has just a dash there. Use Pythagoras' theorem to find the length of the side AC. Now I want to bring you to pronunciation of this because I can do better. So we will go to our tables. We'll go to the geometry section, which I haven't bookmarked yet. Let's go to our right angle section and go up to the geometry section from there. That's our coordinate geometry, so I've just whizzed past it. So I'm holding down my what's it called, my space bar, and I'm looking for geometry, which comes before coordinate geometry. Where is it? There. Okay. And I'll just take the word notation and I'll bookmark that. Sorry, that's just a bit of housekeeping I had to do. So here we have, and I'll jump over and back here. So when I see this this notation, I need to know how to pronounce it. So let's see how we pronounce it from the tables. It says when you encounter this, you should say line segment from A to B, and that's on your tables on page 17. Okay, so from page 17, pencil is blunt. I'll sharpen up my pencil later on, a bunch of them. So I always say start your exam with a whole pile of sharpened pencils if you like using pencil, which I do. Use Pythagoras to find the length of the side. What is it again? To find the length of line segment from A to B, from A to C. So to find the length of line segment from A to C. Well, we could have maybe figured it out because we were given the other two. So when we want to say the length of line segment from A to C, we can say this with the line segment bars or the distance bars. Okay, so rather than introduce an X, which you could do, you can also, you know, notice that this can be called a C. Sorry, I didn't switch over again. I really have to work on my camera work here. So rather than introducing an X along here, I can call that a distance from A to C. Okay, and I think I might be getting on a little bit better, keeping things a bit simpler by using this. So that's it there on page 17. So you see, I've said, yeah, you're talking there about they said distance of line segment from A to B, but a much more elegant way of saying that is with your bars. Okay, so they want us to find a length this time, so we have to use the square root button. But before we do, and because we're learning now, it's very important that we make sure we write a diagram so that we guaranteed our work of merit marks, no matter what else happens. And we should be writing down the formula in Pythagorean form, in its original form from the tables, on page 16. So no, they're actually opposite each other, so when you have page 16 open, and I'm encouraging you, if you have enough space at all, leave the logbooks open, don't fold them over. Okay, and now we'll just go ahead and acknowledge that this is the hypotenuse, so we can apply the square root operation to both sides. Okay, remember we talk about operations and inverse operations. So we're applying the inverse operation of square, so we're applying the square root to both sides, giving us C equals the square root of A squared plus B squared. So in our case here, AC distance, the distance from A to C, is equal to the square root of 5 squared plus 12 squared, a very famous Pythagorean triplet, so and it'll come out to be 13. You can do it in the calculator. It'll be the square root of 169, and that'll be equal to 13. We need a unit if there is one, but there isn't, so we will write the word units. That's best practice. That's the difference between 9 out of 10 and 10 out of 10. Okay, and we move on. Reading now for understanding. Where's my ruler? I'm going to go like this. Calculate the length, underlining our keyword here, of the side marked with the letter in each of the following triangles. So length A we will get with a plus. You can kind of draw in your plus here. A equals the square root of, let's put the big square first, then the small square because we can, and that's equal to the square root of 13. And look, they have said leave it in square root form. Great, they did, but we want to learn as much as we can. So I want you to predict what will the leading number be if I take a square root of 13. So what you know is, you know 3 squared equals 9, and you know that 4 squared is 16. So it's nice to think that will come out leading with a 3. So I can even write it down before I even put it in the calculator. Okay, you're learning so much, aren't you? And sure, look, I have a calculator here, I have one here. Which one can you see better? I think you can see the one on the left better. Okay, so square root of 13, shift equals, otherwise we're not learning anything new, 3.6. And just for fun, we can go back and say, but sure, I could have done the 2 squared plus the 3 squared, shift equals. Super. 3.605 ... and then depending on the context we might do approximately equal to this. Now I can write 1 decimal place there, but I don't have to because I can see it's 1 decimal place. Okay, now we have a leg, and a leg needs a minus. We'll do this quite quickly though. I'm going to speed things up here now. I'll go straight over here and take it that I would write this down as well. Okay, so you're going 7 squared minus 3 squared. We will look at it in third form, and we'll always write down its third version, which is 2 root 10. Okay, and then we'll continue on to our shift equals for our approximation. And actually we're just going to have a practice of let's leave it there. So let me decide as I go how many places. Okay, because I want to speed things up. And now we're back to a hypotenuse. If you want to learn how to spell it, keep spelling it. Okay, we're back to a hypotenuse, and it's as a length, so we're going in with a square root of, it's a plus plus, so it doesn't matter, so it's 7 squared. Where they meet has a plus, and where they meet has a t for tan. So there are two cool things we can remember. 7 squared plus 2 squared, 49, and 2 is 4. Well, hang on a minute, I'll just use the calculator so we can get plenty of practice. Clear root 7 squared plus 2 squared equals root 53. Shift equals, let's go 7, but equals approximates to 7.28 units, centimeters, units, centimeters, units, centimeters. Question 4 is gone. Why am I looking at, oh, because there's bits and pieces of 4. So on we go. So there's more of 4. Calculate the length of the side marked with a letter in each defined. Okay, I get it. So let's just go calculator time now. Square root, okay, it's a leg, so we're subtracting using the big number first. 6 squared minus 4 squared. That's really important, what I said a minute ago. You've got to first identify the case. I need to get a blue pen, so I'll just finish this one up, and then I need a blue pen as well, just for writing things like this. But I'll have blue pen more than black pen for when there's black writing here. Identify the case, and there's two cases here when we're using, so your case, you're getting distance, not area, and then it's either one of two things. It's either hypotenuse or it's a leg. One or the other, or leg. Okay, on we go here. We'll do an equals 2 root 5 and a shift equals 4.47. We'll come back to our units and our units. Okay, it's a hypotenuse. Okay, want to see something cool? If you divide by 3, it's 3 and 4, and that would be 5. And you scale back up by 3, you get 15. So there's a trick of the trade. Just saw it there first time. Okay, 5 and 13. Sure, we identify that as our common one with 12 here, because we're just like we know the 3, 4, 5. We might start getting to know the 5, 12, 13, which I've identified there. So I did both of those by inspection. Okay. And I'll leave it at that, and we'll continue the video later.